Hello everyone. In the last class we saw about the matrices, how a matrix is generated, how it is written, what is an element, what is the order of a matrix, then depending on the orders, how many elements that the matrix can have. These all things we saw in the previous class. Also we saw the equality of matrices, like whenever the matrices are equal, then in that case their corresponding elements are same or equal. So today we will see about the operations on matrices. Operations will include addition, subtraction and multiplication. The division part is slightly different, that we'll see later in the coming videos. So first we'll see the addition of matrices. So whenever two matrices are to be added, the first criteria that it has to satisfy is that both should have the same order. So if I want to add matrix A plus B, both should have the same order. For the convenience, let us take a 2 by 2 matrix. If I want to add this to matrix B, then matrix B should also have same order, that is 2 or 2 by 2, whatever you can say. When we add these two matrices and we get the third matrix, the procedure to add them is we add the corresponding elements of both the matrices. So the 1 1 1 1. So here it will be A plus X. The second element would be B plus Y. Here it will be C plus Z. And finally D plus W. This is how we will add the matrices. First criteria is they should have the same order. The method to add them is that you add the corresponding matrices. Please note that the order of this matrix is m by n. Right now it is 2 by 2, it's a square matrix. You can perform addition of matrices on a rectangular matrix as well. So if the matrix A is of order m by n, and write slightly bigger, m by n, matrix B should also have m by n as its order. And when you add these two matrices, matrix C that you get will also have the same order. Remember this, when two matrices are added, obviously they have to be of the same order, and the final matrix that you obtain will have the same order as that of the first two. Now if the order of both the matrices are not same, in that case you cannot perform the addition function. So in that case, the A plus B, suppose for example if we take, in this particular case, addition of A plus B is not defined. Why? Because they have different orders. Now try to solve these few problems. Now the next operation that we perform is the subtraction operation. It's very similar to the addition one with a minor change, of course. If you want to do A minus B, that is this is matrix A and this is matrix B, to subtract it, I guess you can pretty much guess the way it will be. This element will be A minus P. The next will be B minus Q. The third one will be C minus R and D minus S. Basically whatever is elements are there in this particular matrix, they will have a negative sign attached to it. Make sure if any of this element is negative, then it will become positive, because minus of minus will make it positive in this particular operation. You have to take care of that. Now again, for this 2 by 2 matrix, it feels very simple. If the matrix is bigger, let us say maybe 2 by 4 or 4 by 2 or maybe another rectangular matrix, then you have to be particularly careful about the addition and the subtraction operation. Again in subtraction operation, the order of both the matrices should be same. That is, if this is m cross n, this also should be m cross n. And when you perform this particular operation, whatever matrix that you get will have the same order. Now try to solve these few problems. Now the next operation that we will see is multiplication by a scalar. Scalar is basically any particular, maybe a real number that has to be multiplied to a matrix. That we will see how this particular operation has to be carried out. So whenever you are multiplying a scalar to a matrix, suppose this matrix A is there having Aij, that's the element, and this is the order of the matrix. And if you multiply a scalar k to it, k is any number that we are multiplying to the matrix, then the matrix k times A will be k into Aij. What this means is that each element of matrix A will be multiplied by this particular scalar. This is your scalar that you are multiplying. For example, I will just take a matrix A which is this. I would like you to guess what is the order of this matrix. It is 3 by 2 because there are 3 rows and 2 columns. Now if I multiply a scalar, let us take maybe 10 to this matrix, then 10A will look like this. If you observe here, each element of this matrix has been multiplied by a scalar 10. Now the scalar need not be a natural number or a positive number or maybe an integer. It could be a fraction also. So if we take another example of such a matrix, if this A is multiplied by half, then half times A will look like this. This is matrix half A. You can also multiply a negative number to the matrix. So for example, if I multiply this matrix with -1, then the matrix will look like this. So to understand this particular concept, K is any scalar that is being multiplied. Whenever you multiply a scalar to a matrix, that scalar gets multiplied to each element of the matrix. Please note this down. To get a negative of a matrix, what we do is multiply it with -1. So minus A is called as negative of matrix A. Now try to solve this particular exercise. Now we will see properties of matrix addition. The first property that is there is the commutative law. I am sure you have heard about this commutative law. Basically what it says is, if we add matrix B to matrix A, it is same as this. Basically what commutative law tells you is that the sequence of addition does not matter. I take A first and add B to it, or B first add A to it, it does not make any difference. Both this will be equal. The next is associative law. In associative law, I am sure if this particular concept, associative law, has also been encountered by you in the 11th standard. What it says is, I add this 2 first in the bracket and then add C, or I add this 2 first and then add A to this. Both will give me same answer. Both are equal. This is your associative law of matrix addition. The third property is existence of additive identity. What it means is, for any matrix A, if I add this additive identity, or I perform this operation, then in that case I will get A only. What it means is, this particular matrix is called as an identity matrix. It is called as an additive identity. Meaning if I add this to any matrix, I will get the same matrix again. It doesn't matter whether I add it after the matrix or before the matrix, I will still get this. In addition property, this is a null matrix. I'm sure you remember what's a null matrix. It's also called as a zero matrix, wherein all the elements of the matrix are zero. There is no proof required as such, but if this is matrix A and if I add a null matrix to it, what I will get is the same matrix again. Hence this is the additive identity. The next, that is fourth property, is existence of additive inverse. As per this property, what it says is, if there is matrix A, then there always is matrix minus A, which will give a null matrix. Meaning, for matrix A, minus A, that is negative of A, is the additive inverse of A. Because after adding both of them, you are getting a identity matrix, which is a null matrix in this particular case. Thus, minus A is the additive inverse of matrix A. It's also called as a negative of A. Now we will see properties of scalar multiplication. If we have a matrix A, which is denoted like this, and matrix B, which is, I have taken it of the same order, and K and L are the scalars, then the first property is K times A plus B is same as, this is pretty much same as how you would expand your bracket when you are solving regular mathematics problems. The second property is also very simple. What I have done is expanded this bracket K times A and L times A. You can pause the video and note it down. Now we will solve a small problem and see how these particular properties apply. So this is the problem that we are going to solve. A matrix A and B is given. Both are of the order 3 by 2. And you have to find X such that this particular equation is given. We have to find matrix X based on this particular matrices that are given. So first what we will do is, we will figure out how exactly we are going to get X. It is 5B minus 2A. You don't have to worry much about the matrices. They behave exactly or more or less similar to how you will do with your real numbers. Whenever you take this 2A on the other side of the equal to sign, it will become a negative, so minus 2A. And then this 3 I will cross multiply and make it 1 upon 3 on the right hand side. So for that, first we will have to calculate what is 5B. 5B will be now I will calculate what is 2A. So now we have got 5B and 2A. What we need is 5B minus 2A. So I will perform that operation. So my 3x will be 5B minus 2A. Ideally, what you have to do is write down both the matrices here and then finally write down your solution. So I will continue with that. This is my 5B minus 2A is this will be equal to 10 minus 16 will be minus 6. This will be minus 10. You can pause the video and solve it on yourself. You can cross check with your answers later. Now this particular matrix that I have obtained is actually 3x. What we need to find out is matrix x. So what I will do is cross multiply this 3 on the other side. So my matrix x will be 6 minus 6 upon 3 will give you minus 2. This will be minus 10 upon 3. Next will be 4. This will be 14 upon 3. Next will be minus 31 upon 3. This is your matrix X. Now we will see multiplication of matrices. In this case, what we will be doing is we will multiply two matrices together. So if we want to multiply this matrix A with matrix B and obtain a third matrix, that is C, then there is a criteria which has to be satisfied. What is the criteria is that, suppose this is my matrix A and the order of this matrix is m cross n, then matrix B that is there should have this particular order. What it means is the number of columns in matrix A has to be equal to number of rows in matrix B. Since from the previous lecture you should remember that, you must be remembering that this is standing for RC. That is, m is the number of rows, n is the number of columns. So the number of columns in matrix A should be equal to number of rows in matrix B. Please observe this. And when these two matrices are multiplied, the third matrix that we get will have the order m cross p. Number of rows is from matrix A, number of columns is from matrix B. For addition and subtraction, both should have the same order, but for multiplication of matrices, this is the criteria that has to be followed. The number of columns in matrix A should be equal to number of rows in matrix B. Now that we have understood the criteria for matrix multiplication, now we will actually carry out the multiplication of matrices. Just observe that this is matrix A that I have taken and this is matrix B which I have taken. Now what criteria that I have told you just now is that this number, whatever is the digit here, it should be same as this. Now in this case it is equal to 3, both are 3, hence the matrix multiplication is possible. If at all, if you find out that this and this number is not matching, that is the number of columns here and the number of rows here are different, then in that case matrix multiplication is not possible. Here in this case obviously it is possible. So when I multiply these two matrices, I'll get a third matrix which is obviously matrix C. So I will start multiplying. I'll write this multiplication, this matrix C over here. So now the procedure is this way. Please observe. I will take the first row of this and first column of this. Remember RC. We are still following that RC. Row from the first one, column from the second one. Row first, column second. What I'll do is I'll multiply this L with A, L into A, plus M into D, plus N into G. This is my first element here. To get this second element in the matrix, please note I have just got the first element of this matrix. After multiplying the first row and first column, corresponding elements are multiplied and they are added. Once I do that, I'll get a number which is the number in the first row and first column of the answer, that is matrix C. Now I need the second one here, so what I will do, I will multiply first row and this time I will multiply the second column. That will give me element A12. If you remember this, A12, element from the first row and second column. So I have taken first row, second column. The procedure remains the same. First element here into this, so it will be L into B plus me and H. To get this particular element A13, I'll clear this off, this is just for your understanding. To get the third element here, I'll multiply the first row, third column, so it will be LC plus MFNI This is how a multiplication of matrix is carried out. Now again, to get maybe I will get this particular element now. For this, the address or that you call it is A21 because it is in the second row and first column. So what I will do is I take the second row from this and first column here, so it will be P into A, Q into D, R into G. All these three are to be added. Whatever is the answer will come over here. Now to get the element A32, that is from the third row and the second column over here, what we will do is from this particular matrix we will take the third row and this matrix we will take the second column and corresponding we will multiply. I just highlight it so that you get a better picture of what exactly is being carried out. So we will multiply corresponding elements, so it will be X into B plus Y into E plus Z into H. This is the method of multiplication of matrices. We'll solve one problem and get the clear understanding of how exactly the matrices are multiplied. So for example, I have taken two matrices here and the target is to multiply them and get the final answer. First thing that you will see, first thing that you will check is what is the order of both the matrices. Your criteria that has to be satisfied is this should be equal to this. In this case it is, so we will continue with the multiplication. The final matrix that we get in this case will be of the order 3 by 3. If you remember from the initial example that I have given, so whatever is here will come first, number of rows and number of columns, so it will be of the order 3 by 3. So let us start multiplying. So I multiply this 1 into 2, 2 into 1, 1 into 1. So it will give me 2 plus 2 into 1 is again 2 plus 1 into 1 is 1. This is the first element. It will be equal to 5. Then the next element over here will be 1 into 1, that is 1, plus 2 into 3, 6 plus 1 into 1 will be again 1. The next will be 1 into 0, 2 into 2, 1 into 4. This is how we will continue. For this particular second row, first column, what we will do is we will choose the, I'll just highlight it so that you get an understanding. We have to multiply second, we need this particular element now. So it is in the second row and first column. So we will choose second row and first column over here. So I'll multiply 3 into 2, 6 plus 1 into 1, that's 1, plus 0 into 1, that's a 0. To get this particular element, I will multiply second row and third column. So 3 into 0 will be 0, 1 into 2 will be 2, and 0 into 4 will be 0. So this element will be 2. And so on, you can continue. We will see what is the answer of this. Once you have completed the multiplication, it will look like this. These are the particular rows and column and the elements, and the final answer is this. So when you multiply this matrix and this matrix, what you get is this one. Now we'll see one more example to understand the multiplication concept clearly. So now we'll solve one more problem. Here we have to multiply these two matrices. First, what we will check is whether this multiplication is possible. So for that we will observe this. Since both are same, it is possible. So our target is to multiply these two matrices. Now again, we have to identify what exactly will be our final answer, the order of the final matrix. So it is 3 by 3. So let us start multiplying. First row, first column, 2 minus 1. First row, second column is 2. Then 3. You start solving with me. This will be 3 minus 2. So it will be 1. This will be second row, second column. So it will be 4. Second row, third column. So it will be 5. Now we will move on to the third row. So it will be third row into first column. This will be minus 2. Please note, this will be minus 1 into 1 will be minus 1. 1 into minus 1 will be again minus 1. Minus 1 will be minus 2. Next will be plus 2. And the final one will be 0. Because this will be minus 1 and this will be plus 1. This is how you will multiply the matrices. Pause the video and note it down. Now try to multiply these two matrices. The answer will be given there. Now if we have two matrices, matrix A having order 2 by 2 and matrix B having order 2 by 3. If we multiply these two, first we will check if it is possible. Yes, it is. The answer that we get here after multiplication, which is matrix C, will have the order 2 by 3. Now if we try to multiply B into A, then the order of B is 2 by 3, order of A is 2 by 2. We will check if the multiplication is possible. You observe here, this is 3 and this is 2. Hence, the multiplication of these two matrices is not possible. This brings us to an important conclusion, that is, if A into B and you have B into A, both need not be equal. Both need not be equal. It may so happen that A into B is possible, but B into A is not possible. Or it can happen that A into B is possible, B into A is also possible, but they are not equal. We will see that in the next example. Now I have taken two matrices of order 2 by 2. One is matrix A, that is this, and matrix B is this. First I will multiply A into B, and after that I will multiply B into A. We will see what exactly the results that we get here. So for multiplication, this will be 4, 1 into 1, 2 into 1, this will be 3, 3 into 0, 4 into 2 will give me 8, and 3 into 1, 4 into 1, this will give me 7. A into B gives me this particular matrix. Now I will multiply B into A. You can simultaneously continue to do so. This will be 3. This is 4. This is 5 because it is 2 into 1, 1 into 3, and then finally 2 into 2 plus 1 into 4. We had seen equality of matrices. In that case, what we had said is for the two matrices to be equal, they should have the same order and the corresponding elements of both the matrices should be same. But here if you observe, this matrix is of order 2 by 2, this matrix is also of 2 by 2, but the corresponding elements are not same. Hence, A into B and B into A, they need not be equal in matrices. In real numbers, however, we of course observe that A into B is always equal to B into A. For example, 3 into 5 and 5 into 3 will give you the same answer, or maybe 2 into 4, 4 into 2 will always give you the same answer. They are commutative. You can multiply either 2 first or 4 first, whatever, it will not make any difference. But however, in terms of matrices, it does make a difference. A into B and B into A is not same. Whenever we are dealing with real numbers, what we observe is that if x into y is equal to 0, then what we can conclude is either x is equal to 0 or y is equal to 0. But when we are dealing with matrices, this may not be true. I'll show you with this an example. If matrix A is this and matrix B is, these are the two matrices that I have taken, and I will calculate what is A into B. So this will be 0, 1, 0, 2, 3, 4, 0, 0. When I multiply these two matrices, the answer will be 0, 0 into 4, 1 into 0, 0 into 3, 2 into 0, 0 into 4, 2 into 0. This is a 0 matrix, a null matrix. A into B, here A into B is equal to a 0 matrix, but none of them is a 0 matrix. Hence, if A into B is equal to 0, it does not guarantee that either A is 0 or B is 0. Cannot say so. It is evident from this particular example.